Let's make sure here. Yeah, we got my monitor showing here. So this is a little bit about us. Um, we're engineering and services company. We use the software day in and day out, and so I think that makes us a much better support. I'm down here in our shop right now. I manage our shop, and we make parts day in, day out, and utilize NX for our 5-axis DMU50. Um, we want to make sure that our customers are getting the best use of the software, and we feel that we can better answer those questions and support you better, being that we're not just sitting around doing demos. We actually use the software and run into the same issues or questions that you guys might. We're always trying to use the latest technology and test the new features, test the new releases when they come out. So we try to stay ahead of our customers and be able to give them a better input onto, when might be a good time to upgrade and what are the advantages. So what I want to show today is some of the tools that we feel kind of are those, aha, or, just kind of the tools that we find the most useful and the easiest to get started on 5-axis. We have a lot of customers that, potential customers that really, when they get to that new 5-axis machine in, they kind of hit a wall and they're not able to create parts or get a good post processor for their machine. And that's when they reach out to us and we're able to help them. So I want to show kind of the, maybe you're struggling with 5-axis and how we utilize some of the easier tools and how easy it is to create that toolpath in NX. Like I said, we have our 5-axis is a DMU50 with a Siemens control. And, when we got it in, received the machine, we had it running 5-axis parts on the second day. We create the sim kits, the posts, everything in-house, and we've done that for anywhere from lathes, mill turns, 5-axis, regular 3-axis machines. But we're able to get customers up and going faster than we find others in the field. And definitely that's important. You don't want your machine sitting around. So here I have one that I thought is kind of a cool looking part. It has some undercuts here, multi-side. I can show some 3+2 machining, some hole recognition. I haven't, I find that customers don't really like canned demos, so I haven't ran through and pre-programmed this. I just found this on GrabCAD and got it set up this morning as far as at least pulling it into the machine, getting the setup, the initial setup already configured. But yeah, so we have a part here that has some undercuts, and so I wanted to show the contour profile and also, like I said, the hole recognition. So I'll get started on that. So I guess the first thing I'll show is the hole recognition, and basically there's kind of two ways to go about this. You can do the full feature-based recognition and then have it actually create the toolpaths and bring in tools. What I wanted to show is just creating, recognizing them and then attaching your own toolpath or drill operations to those groups. So I'll go ahead and do the recognition. What we really like about this, especially when it comes to like deep cavity molds or areas where you have holes that you might have a collision, is that it automatically is doing collision avoidance. It's picking up the tool axis for you. You don't have to create separate CSIS objects to program the holes. So if they're all at different tool axes, it really saves a lot of time. We have some customers that have gone from 6, 7 hours of programming down to an hour, just because if there, in some cases you might have 1,000 holes, and those are all at different uh, angles, and you'd have to create separate operations and recognize the axis of that hole. But with feature-based machining, um, it it actually creates that inside the operation. All right, so let's see here. All right, and then it's basically going to group the holes in similar sizes, depths. You can kind of filter even more than that. Um, so here we've got some holes that recognized on the bottom, and then the rest of the holes that are around this feature or this part. So they're coming from all different sides. And so I'm going to go ahead. I believe I have a tool at least. Yeah, I have some tools. I'm going to use the 1/4 inch, or we might need to create one here. Sorry, this is the drill. And then insert operation. Just going to pick a regular drill operation, like we were using a carbide. Make sure it's in the right group here. So here I just generated it. It's given me some, it's given me an error on the tool, so we can look at our tool geometry here. Everything looks okay there. So as you can see, it recognized each hole and created a drill operation for every hole. Um, if I wanted to double check that I had the right size drill, I could measure it, or I can even orient the tool to the hole. So this is without being in an operation. I can um, make sure I have the clearance, make sure it's going to fit in there. The other thing I can do is actually even move the machine around so that it will orient to that. So now the machine head will move to wherever I move the tool. And so you can see this is, if I look at it from the front view here, it's rotated B and C so that it would get the hole. So this just allows you to kind of play around before creating an operation, which can be handy for seeing, what kind of holder length you need, what kind of stick out. Can even be useful for when quoting parts and not wanting to, take the time to create operations, toolpaths. You just kind of want to look at how you're going to machine it. So we'll go ahead and simulate this. And so this is full G-code simulation. It's not doing the internal toolpath. It's actually posting it in the background and then bringing in the posted code to the simulation. So as you can see here, um, this is Siemens G-code. And so it looks like I need to turn on Traore. So it has a couple different, the default is it'll pick up swiveling, but I want to go ahead and do this all in one with Traore. And so I could fix my depth, of course, reorder the order of the operations and which holes it does, but you know, just wanted to show that these kinds of holes could take some time to program in some systems, and here we were able to do it in a few minutes. But of course, you can go in and um, reset adjust what you need for depth, actually how deep you want to go through the hole, whether you want to do PEX cycles. One thing we find, we've had to do some deep hole drilling, even interrupted holes, and that's all kind of built into NX, where you can have it go into a pilot hole and turn up the RPM. Once it goes into the pilot hole, it recognizes where the material is, um, and calls out, goes to the bottom of the hole, and then stops the spindle and pulls out. So for ordering, you can go in here and just kind of choose different methods of resorting. So we'll look at this. So now we're actually going through the hole. If you have any questions on this, let me know, and I can, here, I'll expand the questions column. Just go ahead and type it into the GoToMeeting, and I'll try to answer those questions if we have time. All right, and then the other thing, just trying to, so if you want to have, this also has automatic collision avoidance, so I'll go ahead and shorten my tool and tool holder to kind of show how that works. So let's exaggerate the length here. So I believe that will obviously cause some collisions. So right now we're set up for, here's where you have your how far above the hole to start and how far through the hole you want to go. And then we have our clearance, what we're asking it to check against for clearance values of neck, shank, and tool holder. And so these are the holes that it can get to, and it's not generated the other holes that would cause a collision. And so that's, let's see, we'll check that for full depth there. So that one's is colliding there. I'll go ahead and increase that value a little bit. There we go. So like I said, I didn't have this prep. So what that was is I didn't have it under the right group. Here we have the recognition of that area for collision. And if you don't have it in there, it's as part of your geometry, then it won't recognize it. All right, so those are the holes it can reach now. Of course, this is exaggerated with that tool length being so short. All right, so now we want to go in and mill these undercuts, and maybe you don't have time to order a tool, or we find that our 5-axis on having to have special tools, we can go and cut many features that we previously couldn't, and we would have had to order custom tooling. We're able to go in and just create a 5-axis toolpath and mill parts, definitely reducing our stock in tooling. So I've got a version here. There's a couple different ways you can go about this. In this case, I've chose to delete the holes, and I can show the process of that. It's pretty easy. So if I was to, I already have it done, but I'll kind of show you what that looks like if you have to do that on your parts. So here we have the holes. You can simply go to delete face, have it, this is basically filtering by hole by size. That's one of the ways you can delete, and then just say OK and all your holes are gone. So this is really, this is great when you have, obviously more holes than this. This wouldn't take too long, but we've had several parts where they have 800, 1,000, 1,500 holes, and this saves a lot of time and reduces selection. Since I had already done that, I'll go ahead and undo that and then continue on here. All right, so we have a clean face here. It's an undercut. It's a 10-degree undercut. So I'll go ahead and go back into manufacturing. So I had switched over to modeling there. Um, like I said, it's all in one. You don't have to open different software to do your different functions. You have everything you need right inside of NX. So I kind of created a start operation here, but I can also show, I'll go ahead and create a new one and just choose the same tool. I'm using a 1/2-inch end mill. Go into our multi-axis toolpaths and then contour profile. And so this is one of the, it's just a great tool. We call it, it's called contour profile. It's really quick for creating multi-axis toolpaths. It works if you have a wall and a floor, but in this case we have just a wall. So this is a little bit different. So I thought I'd show that because the floor wall case is a little bit easier. So basically I'll just specify my wall, have it automatically generate a floor, and we can put a negative offset on that so we can go beyond the wall. I'll go ahead and just create the toolpath. So one selection, basically just this operations from scratch, and just made a face selection, and we already have a multi-axis toolpath. So we're able to do that undercut. Now if I wanted to have, as you can see here, the engage is just straight into the part. So I'll go ahead and set that to a smoothing, which I use a lot. And then regenerate. And so it basically set the value you want to avoid the part, but it'll create a nice smooth arc in and out of the cut. And then of course, like I said, we're not going quite low enough, so I can either drag this down or enter a value. So I just kind of drag down the auxiliary floor that it generates, and then I'll recreate the toolpath. And so now it's lower down below the walls. If I wanted to do the other sides or the other undercuts, I could simply, let me get rid of the one we're not using here. I could just basically copy and paste and reselect a different wall. It remembers my negative offset there. Need to specify a different entry vector here. And generate. And normally when I'm programming a part like this, so that I had to select the face. What I tend to do, just to be a little bit more organized, is create. So let's get rid of a few here, and I'll show a different way to do that. I'll even get rid of this other one temporarily. I find that I don't want to select parts or faces over and over again, so I create these groups that I can put my selection inside of. So I'll just do a few here. And of course, you'd want to name it, something more meaningful. But this helps when maybe replacing this part and programming another part. If it's more descriptive, then you'll know what area that the toolpath and that geometry group was used for, and it makes it easier to reselect features on a new part. It also just helps stay organized. So I'll do one more here. All right, so what this allows is instead of having to reselect and copy and paste, I can just drop my operation into a group. It's going to inherit the selection. So I'll just keep pasting it here. And then if I generate here, I'll get my first undercut. And generate, get my second here. So I'm just basically telling it what direction to enter from. And we certainly have toolpath types that you can do all of these in one, but like I said, I find this one really easy, and it's a great way to introduce someone to 5-axis. All right, and then to show a little 3+2, milling, I'll go ahead and I've got my stock hidden, but here's our stock. So we're a little bit out of order, but we can resort these operations or toolpaths as needed. But let's go ahead and add, maybe facing and at least some facing, and maybe we'll do some roughing. So if I insert operation, one that I think is a great toolpath for facing and automatically recognizing where material's been removed is the floor wall. And then we'll go ahead and just say OK. Pick something for the floor. The only change I'll make here, well, of course, right now it's on zig. I'll leave that. But I'm going to say that I wanted to look at the entire blank geometry and then generate. So, of course, the top's fairly easy. I'm sure everyone who's currently programming using 3-axis doesn't find that too challenging. But if I wanted to do that on any other sides, basically I just select the floor and generate. And so we could, this one currently isn't looking at the fixture, so I'll go ahead and drop that under the fixture group. And so now it says, oh, okay, you don't want me to cut that, which is probably better for the machine operator and probably for the machine. So here we go, we'll do another side here. And then, so right now, if we wanted to, let's move these up to the top. This is our program order view. So this is representing what order we'll do everything. And our drilling operation is looking at the in-process work piece. It's also looking at so that it's looking at the state of the stock, and it'll automatically avoid any features that are in between. So I'm trying to think of a way to maybe show, yeah, I could show what that, so it's going to try to avoid anything that, say if you have an island in between holes, I find that people struggle with trying to miss those type of features with drilling operations. Ours is looking at the 3D part, the 3D blank. Um, but let me go ahead and set this drill back to something a little longer so we can clear. Let's see. That should be, let's go a little longer. All right, so now we can do all of our holes. There we go. So let's say if I had, you know, since we have modeling here, I'll go ahead and extrude a little fake feature. We don't want to make it too tall. Unite that. So now if I go back to my drilling, as you can see, it changed its method to avoid this. So it's a really, really handy. I mean, this is, here we've gone and created multi-axis drilling quickly. It's smart. It's going to help us avoid crashing our machine. It's going to miss any features or changes to the part. If we were to go and do this, so if we do spot drill or any other processes on our hole, it's going to look at those changes and update as far as if it doesn't need to go all the way through, or it's just a smart drilling operation. So our one facing toolpath will probably have some issues. We'll see if it tries to, I'm not sure if I did that side. Let's see. I might not have faced that side. Oh, I did. There it is. It's trying to, it avoided it, but not doing much machining, and that's okay. All right, so we'll delete that. That was just kind of a there, but before we'll do some roughing to get away this. But as I'm thinking about it, I guess another thing, when we're doing vacuum molds, sometimes the holes, the angle of the hole doesn't allow us to get in there and machine it. Our customer's okay with us updating that as long as we create the hole. So I'll go ahead and show, how NX helps to make those kinds of changes for those scenarios. So I'm going to go and re-angle one of these holes. So I'll switch my layer over to the part that has holes. It might not, I won't be able to do too much because of, I mean, I'm faking a little bit. Maybe I'll make it a little smaller diameter and angle it, because at this diameter, it's not going to be, I'm not going to be able to angle it too much. So I can resize, whether this was a step model, a parasolid. Right now, this isn't something that's been modeled in NX. I'm doing everything on a dumb solid. This resize face, it recognizes the current size, and I can change the size of the hole. Right now, feature base is looking at changes, and so that's why you saw that update there. But I can go and, let's give this face some angle here. So I'll give it what to rotate about. Actually, sorry, I wouldn't want it from that. Let's set it to this here. All right, and then what I want to rotate from, And then we'll go ahead and enter some, let's go a little bit more. So you can see I'm getting some tilt there. Let's go maybe 20. Hopefully we'll still be able to drill that hole. All right, I'm just updating the display. I have it on quick here, so it tries to save graphics memory, but I'll go ahead and regenerate that. And let's look at why. Oh, because I resized it. So for now, I'll turn off gouge checking. And so it's going to go ahead and gouge it. Um, and then it's looking at, interesting. Oh, probably because I didn't do it about the midpoint. Let's go change that. So I should do it about center so that the face of the hole also changes in vector. So I'll go between 2 points. That'll work, or it should. And then we'll just move that point there. So we'll rotate somewhere around the center there. And accept. All right. And regenerate. And what I'll do is just re-recognize those real quick. That's normally what I do, but I'm trying to keep on pace here. So let's go ahead and so that notices that hole changed and it wants it to be re-recognized. Let's go ahead and scan again. Yeah, so it recognized it as a different type now. That's okay. Let's delete the ones we don't need. So I didn't filter, by a certain type, so it's gonna recognize everything. So I'll go ahead and drop that toolpath drilling operation into that angled hole. So now it picked up the new vector automatically, and then if I wanted to go ahead and do my other holes, I just paste that inside and regenerate. So it's kind of divided them up a little bit different this time, just based on the changes I made. All right, so now let's do some roughing and leave some time for questions. So let's go to let's create what we call our cavity mill is a pretty good toolpath type for that. So let's find, and I'll just use the 1/2 inch again. And we want that to come after the facing, so let's drag that down. And we'll start by doing the top. And I don't want it to do the hole this time, so I'm going to tell it to avoid basically anything inside of this. And then I'll kind of set it, it'll recognize the entire stock. It's automatically looking at that. So if I was to generate without any selections of my part, it's going to go everywhere that there's material to be removed. And then if I turn on 3D IPW, then it would go only where it needs to remove material. So this is what some refer to as like a rest milling operation. And so it's not going to machine the very top level because it's already been faced. I tend to only use that as needed because it can add time to your toolpath. So there's much easier ways to filter in this case that doesn't require having to scan for where the state of the stock is. On this particular part, you can see it didn't take long. But there are some situations you'll run into that it will add quite a bit of processing time depending on how many faces and how large your part is. So what I'm going to do in this case is just give it, how deep I want to machine. So I could pick features on the part and maybe go a little bit below that. So I'll just say OK and generate. I can also set optional levels where I change maybe the depth of cut between these two levels. In this case, it wouldn't be very helpful, but there are times where you might want to semi-finish a radius, so you can change the cut level depth per cut where that radius is. So I'll just show a little bit of 3D dynamic verification to show kind of what it's doing. So if we wanted to go and get the material from the other sides, yeah, I need to, let's see. I didn't do that other side there, so I'll add one. Let's look at this again. Yeah, so there's some sides I didn't finish face milling. I didn't regenerate that one from the boss, but you can see here it's showing, it's reflecting what that face mill did on the side we did generate a toolpath. I'll go ahead and update those. All right, so yeah, there we go. Now that our boss is gone, it's updated. I'll go ahead and copy one more to do that other side. All right, so we got a few sides there. We're missing one, but that's okay. And then if I wanted to go and do some roughing from a different axis, I can just copy and paste and set my tool vector basically to a face, and then update my cut levels. I didn't have the trim boundary. Let's fix that. I'll go ahead and not select a trim boundary so you can see what that does here. So if we didn't have a trim boundary, of course, it's going to go in the part. If that's preferable, you can do the inside and the outside all in one operation. I'll go ahead and put that inside of my avoidance for the fixture. The reason you can have everything detect the fixture, but I tend to just put the toolpaths that need it. Again, just trying to save processing time. Um, it depends on your computer and everything. This is a laptop, it's a couple, 2, 3 years old, and you can see it obviously it wasn't slow, but I just tend to do it to save time because if I have an operation that's only a toolpath that's only cutting up in this area, why do I need it to analyze the stock or I'm sorry, the fixture? So I just that's my practice and what we tend to use here at Applied. All right, let's go ahead and see what that looks like, and then we can do some verification. I could tell it to do depth. This is by level, so it takes down one level at a time, inside and out. You can change that. And then if we wanted to do a simulation of everything here, all right, and then we get rid of a few folders. The folders is just a different way to organize, so you can post a certain sections out at a time, maybe roughing and then semi-finishing. Basically, this view is like what order do you want to post, and the folder, if you were to post from the top level, it's going to post everything. If you pick just a toolpath, it'll just post a toolpath. So let's go ahead and see how our verification looks. I don't think I have, let me reset that. So it told me that I don't have RPM set on these. So what it will do is not remove material. It warned me, and now it's showing me that, hey, you're not going to remove material if you don't have the spindle turning. So let's go ahead and fix that. I'll just set everything at once to some number. It doesn't really matter in this case. Then we'll go ahead and resimulate. So this is gonna, so drilling still doesn't have spindle speed. It would tell me if I had any duplicate tool numbers, or maybe it's not set to a tool number. All right. So you can choose whether to see 3D material removal or just let's see, let's fix that. So I didn't add my vise, a few objects to the kinematics to move with the machine. So let's go ahead and pick those. That should be it. And of course, if you use a machine template, it would just already be set. So in NNX, you can have basically reuse is huge. Maybe I should set my part to the kinematics. So you can have a template with operations already in it. You can have your tools. If you have standard tools that you set in your machine that are always in there, you can have your template, your start part, if you want to call it, already have the tools that are your standard tools. Of course, you can add more. If you have certain operations or toolpaths that you have set up the way you like it, it can just bring all of those in, and then you basically just tell it what your part is. You pick your part and you pick your stock, and every toolpath is going to look at that. Just inherit it is what we basically is doing in NX. So I don't have to go into each toolpath and say, this is my stock, this is my part. I set those once in a group, and everything under it is going to inherit that and know what material's left, where the part is, where the stock is. And so it's a really nice feature, not having to go and set that in every operation. All right, we'll wrap it up here, but I must have something. Did I not finish my selection when I was talking? Yeah, all right, so let's pick that. There we go. That was a little fast. We have high-speed toolpath types like trochoidal machining, some similar to like a volume mill, or there's different names for it, but in NX we call it trochoidal, basically looping. I don't know if I selected it on this one. This is kind of like I said, an overview, kind of here's how NX works, here how easy it is to create some multi-axis toolpaths, and we can simulate it for you and make sure that you're not colliding with your machine. Here's our contour profile with it's kind of diving into the material, and it looks like I didn't set Triori for those. Let's go ahead and fix that. Triori is for the Siemens control, is the tool center point. So I'll just show those now that I fixed them. Turn off material. A lot of times what we do is just run it to check against collision and not have it remove material. We'll use the 3D verify for material analysis. Just tends to simulate much quicker, and really what we're using simulation for is mainly to detect collisions. Last thing, just a quick thing, if for those that are, hey, okay, 3+2, but what if I need an angle to a certain angle to a toolpath? So on this tool axis section for our, let's do the side one here, cavity mill and a lot of different operations. I set it by vector relative to a face, but we also have dynamic. You can basically angle it however you want. You can drag this around. Let's say we want to machine it like that. Now I regenerate. And because I have the machine turned on, it moved the machine to show what that would look like with the head and spindle and everything. It did update my cut levels, so if I didn't want to go all the way through the part like that, I'd have to change that. And then you can see that our rapid moves are pretty smooth. For this part, since I knew I was going to go around it for multi-axis, I set the bounding area for rapid moves to a cylinder. And I don't have to set that in every toolpath. I just set it once inside of the MCS or G54, if you want to call it, then everything is going to inherit that's my intent. Of course, I can change that per toolpath if I want, but the idea of NX is basically we want you to do most functions once. Tell NX what you want to do, and then from there, everything is going to understand that and look at that. It's all about not having to repeat things like setting preferences and setting what your stock and part is. For the MCS, I didn't have it a very relative location, but I could certainly set it to, maybe the top center of the part just by selecting on an arc, and then that's where my G54 would be. All right, well, I wish I had more time. I could show some other things. I certainly will have more webinars. I wanted to show some deep, we tend to do some very deep molds with an 18th thou drill, and we just love the feature base for it because we're getting our holder within 7 thousandths, 7.5 thou of the mold. We're doing all 800 holes in one toolpath, one operation, and using tool center point to transfer between them. But I didn't have, I need to, yes, come up with a non-proprietary mold to show, and so I'm almost done with that, and I can certainly present that in another webinar. You know, I kind of skipped around there. Like I said, it wasn't real polished. I didn't want to have something practiced and canned. I wanted you to see any mistakes and any issues, kind of see how I work with them or work through them. And I guess some of them I was kind of skipping through a little bit quickly. This isn't really training. It's kind of, I guess, some highlights. And like I said, I can meet with you one-on-one through GoToMeeting, or you can come say hi to us, see our shop, see what we do, and you know, could show you a little bit of NX. All right. Let's see if we had any. We did have a question here. Can't really see it. I'm trying to scroll up here. Uh, there we go. Okay, surfacing toolpath. Yeah, I could show that real quick. That doesn't take long if you want to hang around on the red area there. And then I'll just open it up for other questions. It's good question. Okay, so let's see what we have for tools. Uh, 1/4-inch ball mill. So there's a couple different ways on our multi-axis. Actually, this even doesn't have to be multi-axis. Let's see if you asked about that. I would probably do it fixed. It runs quicker, and I could just angle to that. Um, so I'll show what I would do. And there's two. We have one called area mill and one that's more like a streamline. Streamline, if you have, so it's kind of like you have two flow curves and maybe some cross curves. So on a part that has a boundary that you want to follow, you know, it's a very cosmetic part. It'd be nice to have the toolpath follow those curves that someone in ID or set, you know, spent a lot of time to make them pretty. But area mill I think would work well in this case, so I'll go ahead and pick that. It doesn't really matter in this case whether I pick the part that's, I guess I'll go to the finish part. So I just tell it what area I want to machine, and then I'm going to tell it, you know, kind of what step over. You could do this because it's open. I'll show you follow periphery and then zigzag just to show you a couple different choices. And this will project on the part, so it keeps the step over normal to the part. I think that's everything I want to set there, and then I'll set the tool axis. And in this case, there's a couple different ways. I could specify vector and set it normal to the face. So if I pick kind of in the center of the face, you know, you get a pretty good vector. And then I could generate. It's definitely a tight toolpath, but you know, and then it has a pretty good lead in, lead out. But I really like go to our non-cutting moves here. I like the smoothing. One is for the engage and retract area, the white and actually it's not white. I've been told it's pink or salmon. I did not realize that. And yellow. Then the other is for non-cutting. If you had a lot of transfers, in this case you don't. If you had more than just an initial and a final transfer, it would smooth in between those. So now if I regenerate, you get a little bit prettier arc for your move in. A zigzag pattern, sorry, we can simulate that too. This is actually 3D verification. And because this is the last toolpath, it's just going to remove what all the previous ones removed first from the stock and then show the machining of this one. So it, like I said, it's keeping track of that in the background. There's a little more material left than we'd want to with a 1/4-inch ball mill, but it works. It'd be a little mad, make some noise, but and there we go. So that's kind of one of the areas. If you switched it to, and I have, if you're asking about quality there, I have it on medium resolution. So then you can even change how fine you want your 3D verification, and then a zigzag. And this one has smooth arcs in between. It's just a small step over, so I'm having to zoom in quite a bit, but it basically does a nice smooth arc in between in between each zig and zag. And then here's that smooth transfer I was talking about, and um, we haven't had any issues even using those on our Fanuc machine. Poll.
Yeah, I'll ask a quick poll just as we're wrapping up, just what folks might be interested in for the future. Some of these might be live webinars, and some of them might be pre-recorded videos that folks can access at any time. So if anybody has an opinion, be glad to see what people think. We can get Michael working on that. So we'll go ahead and.
Yeah, I can see the poll here.
Okay. Well, as Michael said, if anybody has any future questions, feel free to reach out to us. We're happy to take them. And we'll follow up with the recording of this session at some point. And I think we're going to try to provide the model file as well.
Okay, yeah, it's like I said, I downloaded it from GrabCAD, so it's open to share.
Great. Okay, well, I'll go ahead and
close. So I see a few people answering here. Looks like for hard to reach machining features, that's a good one. Getting started with a new post configurator. Do you know how once I'm in session, it's not allowing me to unmute attendees, only maybe one at a time.
Yeah, I think if folks have questions, they can type them in.
Okay, all right, sounds good.
Yeah.
Yeah, and then we could unmute that particular person if needed.
Yeah.
All right, well we can, should we leave it open for them to finish the poll, or can they do that after we disconnect also?
I think that's fine. I think we can wrap it up.
Okay. All right, well thank you everyone for joining, and feel free to email me or give a call. I don't know if, let me see if my number was on there, or there's Eric. Yeah, Eric Barber, he can put you in touch with me. All right, well, have a good day, everyone. Thanks a lot.
Thanks, Michael.
Yep, bye.